Hey, thank you, Mike. This morning we're going to finish up the project that Alison started in her time frame, and we're going to talk more about Francis with a group, everybody joining in that has something to say. And we got several other things here that we haven't covered that were big on Francis's list. So the first thing we do is James is going to cut this off because it's a little bit longer than we need. And then the tenon is larger right now, so we're going to reduce the size of it with the tenon tool. And then we'll attach the base there. That's good. Okay. Yeah. All right. So we got the base, we got it shouldered nicely here, and then we'll be putting it in the vise with the false jaws so they won't mar up this piece as much as the square jaws would. And then we'll tenon it into the bottom part here of the so that's the first thing we're going to do here this morning. So we need to get this hot. We got tongs that'll work that. We're going to be talking too about Francis's way of making quatrefoils and tenon gauge that he used, and then his roll pattern. There's another piece of the roll pattern up there that I'm going to get up there and get. Where? Both pieces? Where's the other piece? That's the one I was going to get.
So I made the tenants meeting last night at about 9:30. So I decided that's why we have to rework the file.
Hand me that other piece.
Does that fit with that one there?
I don't know.
It's a long way down for old folks.
That is the right one.
You want to draw it out, or?
Yeah, we'll talk about it a little later. I just want to make sure we had it down there.
So the other night I went home and I made this into something. So in case anybody here hasn't seen it, it looks a little different than it did the other day. So I went ahead and scrolled this all around by hand. The only thing that changed slightly, my forge weld. When I went ahead and bent this other piece around here, you can see it's a little bit higher than what I had drawn. And since it's not critical, I just allowed it to do that. So in pieces like this, you can take that liberty, right?
You can
As long
do a
as it
little
looks
freehand.
good.
If it's inside a round or a square form, then you're more restricted. You got to be more exact.
Right. The other thing, oh, sorry, go ahead.
I'm just standing close to you so the mic will pick up your voice.
I thought you just liked me.
I do.
The other thing that I wanted to point out, this is a really simple piece, but when you have like a big drill project, before you actually put anything together, you're going to want to go ahead and drill all your holes for your tenons and everything, and bolt everything together to make sure it fits properly. And so you're going to want to have over time you would accumulate like a box of various sizes of bolts and nuts so that you can do that in your shop.
Drilling scrolls was one of the things that amazed me the first time I took Francis's class. On the table of the drill press, you move the table to the side away from where the drill would come down and not hit it. And then you clamp a bar across the drill table and then rest this on the bar or channel. We had a bar at the folk school that was kind of rounded, and Alison used a channel when she was working with Francis' class. But the table is right here with a bar clamped across it like my hand would be, and then you drill. Right, if this is a drill press table and the drill spindle's here, then you drill here. And you want to hold the scroll up high. You don't want to hold it down here, because when that drill goes through, it's going to kick and break a drill bit. But that was one of the neatest things I saw there.
And on a
You
bigger
hot,
drill,
James?
it would yank you around. This material's hot, so.
Heat it up just a little bit more. It would probably finish it, but I'd rather. Okay, the sequence of how you do your final assembly is important. You need to think that through, and Francis always said think backwards. Some of the way you would put something together is try to figure it out so that you don't forge yourself into a bad spot or a crack or a hole and can't get out of it. And so in this case, we're going to put the stem into the base here first, and then the tenon into the scroll in the square corner, and then do the collar last. I don't think it would make any difference whether we did the collar or the tenon first, but we're going to be hammering more at an angle when we're working on the tenon than we are when we're working on the collar. It's going to be flat when we're working on the collar. Now, when you close a collar, if it's an outside piece, you always like to close the bottom piece first and then the top piece over it so it doesn't catch water near as much. It's going to catch water anyway, but Now, we already had a fairly well monkeyed shoulder, so I don't think we need to. And I was able to get it right on. Maybe I need to go back in just a hair more.
The beauty of a glove, right? Nice shrink.
Well, give me another little more heat. If your tenon gauge, sometimes this was a brand new one, so it shouldn't have the problem. And generally you put a card in there when you're drilling them so that it'll make a little undersized tenon. And it makes a difference whether your tenon is hot when it went in your swage and expanded, or if it's cold, because you may end up with a larger tenon if your stock is cold than if it were hot. Now we've got more length, so we'll have to cut this off. 3/8 inch stem is what we have here, but the head of a 3/8 inch rivet is larger than a 1/2 inch. So we're going to try to put a 5/16 inch head on a 3/8 tenon, which is no problem.
The rule is 1.5 times the diameter of the rivet for how much material you would have beyond your piece. So for the rivet head. But every heading tool may be slightly different, so the suggestion would be to make sure you do a sample to check it out first. I think we're going to cut this one, what, like decide 2 times, or I can't remember what we said we were going to do.
One diameter.
1 time. There, that's better.
Okay. We're still a little tight right down at the shoulder. Okay, I'm going to close up this just a little bit so it'll be
Swelled it out a little too much when I monkeyed it.
yeah, the tenon tool there may have
Okay.
gotten onto it some. Okay, so what length do we need now? We're going through.
I'm going to 3/8 and 1/2 inch
And we want another 3/8.
Past that.
Past
So we're
that.
looking at 1.25 inches, right?
You got a 1/2 and 3/4, so that's 1.25 inches. Yeah, we can cut it on the hardy, we could saw it, it's a little hot for sawing.
Too hot to sew.
You want to just let it cool and we can talk about something else for a couple minutes?
Yeah,
Okay.
yeah, you could just leave it
Leave it in
there.
Okay. All right. We've got many things to talk about. You want to do the shovel pattern or what would you like to talk about?
I think I can do this quickly enough that it won't take too much time. Ovals, when you're working ovals, I need a pencil that's rectangular, not round.
Oh, I don't know if I brought one.
Well, I had a stub yesterday, and
Did you?
what did we do with it?
Who knows where it went? Let's see, why won't it go in there?
The round is bigger than
Here, let me,
grind it a little bit. Anyway, this is a jig for drawing ovals. This is shelf bracket. I bought this down at Ace Hardware the other day. You set the distance from this, from the pencil point to the center of this at half the minor diameter, or at the, thank you, James, at the radius that you want to draw.
If you want to draw on the back of that, you can.
Well, I probably won't be big enough.
okay, let's get the sheet out.
Okay, I've got it set. Let me make it a little more even number here.
Flat?
Land on the anvil and that.
Oh. Let him get set up first, I guess.
I've got the, it'll set at 7 inches,
Your chair? Yeah.
so it'll be 14 inches wide. And we'll set this one at 12 inches.
Oh, not the same height.
If you leave it on the floor, down and see it, but then he's gonna have to fall in the
Too hard for Clay and I to get on the floor.
Can't get back up if I get on the floor.
Alison, clean
I
the
think
hammer.
the best is between here and there.
Right, let's put it on the anvil. This piece.
Okay.
Oh, well, we got it. Okay. I think we got it.
Now, the biggest problem that I hadn't figured out, and I need some real strong magnets, is to connect this to your piece there. And, yeah, lost my chalk, but here's a. So you're going to have a center, and usually you're going to have a layout line here, and you put the center right over this, and I failed to drill a hole in there, so it won't be. So wherever you want it.
You gotta get this outside.
No, we'll jump over.
We'll jump over, okay.
Okay, you got that pretty. Now get over here. Yeah, we moved.
Yeah, well, go ahead.
put,
I can't.
All right, move your hand over to the other one. And when it's small, you just have to jump over and fill in the space.
Wait.
Okay. So we've got 24 inches since this was set at 12. And this is 14 inches. That was set at 7. So usually you don't have too many projects. John was telling me he wanted to do an oval on one of his drawings, and he found the tool here. When I got here, I only found this half and not that half, so I had to make another one here. And if I can get time, I'll write the instructions on here. Set the first one at half the minor diameter and the second one at half the major diameter. Any questions?
Clay, is there a specific name for this channel that this is?
It's shelf bracket from Ace Hardware.
Shelf brand, okay.
Yeah. You put it on the wall. Now, this piece has to be milled or ground down to where it would slide in the channel. It was ½ inches, just a little bit too large for it. And make any kind of pencil holder, you just need to have a swivels on here, and the ½ inch rod bent does pretty well for that.
You gonna use this some more?
No.
Lay down.
False jaws are real handy. Usually we have them in 1/4 inch plate and 3/8 plate and ½ inch plate. Give you a different radii.
What are you looking for? There's no vice there anymore.
I'll get out of your way, Jenny.
I was so used to the other vice being there.
You just wanted to take the burr off the top of this.
So used to that other vice being there.
This only goes in one way, so. just put it-
Yeah.
Raise it up.
Yeah. Okay.
You want to put some heat in that in the
Yeah, I think we should
Forge.
put heat in it, clamp it, then
Right.
get the torch, don't you?
right.
Okay.
Okay.
So heat it in the forge.
Okay. Get it here.
Need new flint.
Yep.
Joe,
There's nothing in there.
Here's one. Oh. Yep.
Is that functional?
And that should, if that, well, it looks like it should.
we want to use ball peen hammer?
Yep.
Yeah. Where are they these days? Oh, they're in the same.
They're in the same place, that's right. Tables.
Great.
It doesn't function much. Maybe you can rotate that.
Okay, I'll do it.
Yeah, they're in the same place too.
I think we've got more.
Right.
And after we get the tenon headed, we've, well, we want,
Yeah.
we talked about using a different tenon header that James thought up last night for working in a close position, but we were so busy we never got around to do it. I've never seen one, and that's to use a bar. This is a jackhammer bit out of Francis' stash, and put the dimple in here, and then run it cross like the side cutting chisel. And I think that you hold one end, the hammer on the other end. So I think that's probably pretty good. Okay, we put heat in the big piece in the forge so you don't have to try to heat it all up with the torch.
Let's put some more heat on that.
She hammers more than us old men do, so let her do the hard work. How you do?
I'm just smearing it.
They made fun of me because I called this smearing. Thank you.
To the other side.
He lit it with the fire.
And this applies for when you're heading a tenon as well. Whenever you're hammering your tenon, you would need to pull it towards you, whether you're trying to or not. And so I'm just going to get on the other side and hammer on that side too.
Yeah, especially if you got a long tenon, you want to be. You want to watch and be careful and see that your piece is not sliding down in the vise and the piece resting on the vise jaws, because you'll end up with a loose tenon.
The whole piece. Let's see what it's doing.
Show it to the camera. Now hold it right here.
Yeah, right on the bike, fine.
Other side.
I want to heat it one time. So if I want to twist, it's like a little bit twisted that way.
Set it down on something flat.
It's really
Now
sit
you're
there.
talking about here,
I'm talking about the whole piece is,
this piece.
yeah, the vertical piece is twisted a little bit in that direction. Do you see that? Or is it not?
I don't see enough to get concerned about.
Okay.
We could heat it and put it in the vise and yank it around if you want to.
Well,
You gotta heat it.
I know. I want to heat this one more time and work on it a tiny bit more, if that's all right.
I believe you're ready, Clay.
Okay.
You wanna,
No,
you gonna do this?
yeah. Just turn the fire off. She wants to heat this one more time.
Okay, you go ahead, Clay. Got hot metal.
Thank you.
I just wanted to smooth that out.
What?
Hey, drop the Tommy bar. The lights.
It's just a little smoother.
That's it, I gotta go deeper, Clay?
No, I don't think so.
Oh, we just need to stretch it out.
Put this in the hole and see what it looks like. You want to twist it? We'll twist it. Twist it.
It's been kind of freaking me out.
She wants to twist it.
I'll screw it up, I'm sure, if I do.
Which
So we
you
need to
can't.
go in this direction.
Yeah, but you can't see that
I
when you
know.
got. So go to the other side and mark it.
Okay, so
You want to come to this side.
this way, right?
That's what you say.
That's what I say. So we heat the whole thing, or what?
Yeah,
Just
we
part
could.
of it.
We could do it with a torch.
Think? And what do you think we should use? Do you think I should just hit it, or do you think I should use something to?
You could put a bar through here.
You think that's okay?
Yeah. Oh, I gotta heat it first.
Okay.
Now this thing is hot. So don't grab it with your bare hands is what I'm saying. Now you're gonna twist it in the imperceptible amount. Oh,
Oh,
that was good.
Let's see. Yeah, that's better. Don't you think? I mean, look.
Yeah, that's it.
All right.
More square with the
It
piece
is.
there. All right. Well, do I need a bigger ball?
Yeah. You got that one as deep as you can go?
Huh?
You sunk that one as deep with that ball as you can go?
No, but
It'd be good if it was a little bit bigger.
well, we can go deeper with that one. Where did I do with it?
So you can see like
No, we gotta get a bigger one.
how on each side the swell is a little bit different. I think it's going to be, totally stable. I don't see any problem with the size.
I can't find a bigger one.
Okay.
So in order to get that control and the swell,
A little bit bigger diameter round end punch than that one. Or
the option would be to upset smaller material and then do it different. So you can go
we could use this, James.
are doing
It's a little bit big, but
Oh, there's a smaller one.
there is. Put this one up there.
this will be the next step to get that on.
Might want to turn it to the camera.
That's about right.
That's good as we can do.
Yeah, let me straighten it out.
Straight.
This vertical piece, I started with 1 inch square and tapered it. You can see it's got a swell in it to begin with. And so I started with 1 inch square and tapered it down to half, or close to half at the top. And then I just went ahead and forged that square turning on the back side of that. And that was 3/4.
I want to cool it in water a little,
Down tenon on the top, which is
There we can.
but not quench it. Just in and out.
going under the power
Here.
hammer and tapering this piece down, you get kind of this So that shoulder that forms there is just what I utilized. Instead of having to upset it to create a shoulder, I just utilized a bigger piece of material to create the same effect there.
The piece I started with was 1.5 by 2 and
Half.
1.5 by half. Yeah. And I tried to get a 5/8 square in there, but I wasn't able to do it. And in time I got the hole through it, it's thinner than 5/8. So that might have should have started with a thicker piece of stock to get a bigger pass through or tenon mortise.
For the next demo, we'll do it over again. Okay. How are we looking on that tool?
Yeah, we were about ready. I think we can. You got these ball pens you're going to use.
I don't know which ones you want to use.
You got bigger.
I've got, there's
Okay,
there's
those
big
two should be
ones.
fine. These are too small. But on the long tenon, I started to say a while ago, when you make your first blow, you want to be careful because you're going to bend it one way or the other. And sometimes you got to really correct it.
So we had a lot of discussion about putting the head on this tenon too. Whether to use an offset header or
And the other,
a different kind of head.
or make a convenience twist up here and get this out of the way. Except on twisting the stock, it's very, very difficult to get it back to exactly rectangular without some artifact showing of what you did. That's just really tough. So we'd rather do it with start with ball pens from both sides, and then we've got a good solid base here. Can hold it on the anvil to support it. I think that's better than the vise.
I think it is too.
And then we'll go in with the header tool that James came up with last night, and this is what we're talking about as a offset tool, which would go in like this, but this particular tool is too bulky and the offset's not good enough, but by working from both sides we could probably get it done. But we want to try this brand new tool on you. Never been done before.
Clay made a tool.
James came up with it.
James and Clay made the tool.
Frank. Okay.
So we're gonna try to go in like this
All right.
and like that. Are we gonna work together on it or what?
I'll hold and you hammer.
Okay, and then we'll switch around.
James will heat.
I think I gotta use
Okay, you want to put your heat down just as close to the bottom as you can. And you inspect for square.
I think just kind of hold it in line and hold it on the point of my tenon. And don't burn the people who are helping.
Never burned you all. We've been working together too long.
No, we have. I don't know how much I'm gonna get here.
It's a tough place to
It's
get
a tough
to.
spot.
More heat, James.
Yeah, we're gonna have to just keep heating it, I think. Yeah,
Well,
let's switch sides now.
I think let's go to the tool next trip
To the tool. Okay, let's switch sides.
and see if it works well.
Where's my handle?
Get a big one.
Yeah, I'm looking for one. Oh. All right. Where's the tool?
So maybe a convenience bin might have been the
Well, we'll see.
quickest way.
Patience. So I can hit on both sides of this tool, right?
Now, I'll hold the tool over here.
Okay, and I'll hit on this side.
You hit on that side.
And we might have to reverse it, how to
Okay.
It's going.
Switch sides.
Yep.
Heat, more heat.
Yeah.
Yeah.
Getting a slight shoulder here, so I don't know
Yeah.
if you can rock it a little bit.
Can I go to the other?
More heat.
Yeah.
It's tightening it
It's
up.
looking good.
It's
It's
tight.
working.
All right, now how's your alignment?
So you get on the other side, so. Got it? Maybe rock it.
Which way I
It
need to
needs
rock?
to go on this side.
Yeah.
Okay. I think we need more heat again.
Can we get that, reckon?
Yeah, it's strong. I think at least
It's-
one or two more heats.
Okay, hold it.
Don't you? Or do
And
you
maybe
think it's
this-
swelling out too much?
Maybe this is too small.
Maybe we need to make it a little bigger?
Yep.
Can we do that?
Grind something.
Do what?
So we're starting to get a little bit of a shoulder, the heading tool's just slightly big, slightly too small. You can kind of see it's a little bit raggedy looking in here. So we're gonna try to just make that a little bit bigger and smooth that out a little bit. We went with a bigger tenon because we thought we needed it for strength, so that's what we're doing here.
So this is developing a new tool in the front of an audience.
Yeah, right. It seems to work though,
Well,
right?
I think this one.
that one.
Or that one, yeah, that's what I thought.
I don't know. I might need to do, this scroll here is, I'm gonna have to do some more tweaking too. I just want to show that like this scroll is slightly off, and I'm going to adjust that. Yeah.
After we get this socket a little bit larger, then I think I'll go into the roll forms, roll patterns, half patterns, and while the tool's cooling.
Good idea.
The other thing Francis was really on to was bending angle iron by hand. Most of us today, if we had a job bend angle iron, we'd get a Hosfeld bender or a roller that had the angle iron fixtures in it, but he learned from the canners about, in San Francisco and down at the wharf on the canning factories from the angle smiths that how to do it by hand. I've tried it a few times, but I haven't been successful very well, and I don't see any of his angle pieces up here. I don't know. I've got 2 or 3 at the folk school, but I don't know. I thought there would be one on the wall, but I hadn't seen it. Is this the one? I might. We don't want to get down to where.
That's about it.
You don't want to make the heading tool too big either, because then you run into getting marks in your material. So we're doing the best we can.
I need a piece of chalk. I can't find my chalk. Thank you. Here it is.
You want the plate back up, Clay, so you can work on it?
Well, if it would help the camera,
Sure.
It'll help you back.
Yeah, we can.
well, I'd get down on the floor.
We need the automatic. The pop-up table. So we use that and that stool.
Sawhorses or the stool?
Well, we used the stool last time. And
Okay.
Just put it kind of underneath it enough so it doesn't blow too much. There you go.
One of the rules of demonstrating in front of cameras, don't have your butt showing in the camera. I did that up in New England when I demonstrated up there. I put all my tools on the back wall there and searching for tools. They got more shots on my hind side than they working. Okay, this is a small scale model of what you might need for a square forge hood. This is a half pattern, so you would have to run it twice. And this would be the size of your ductwork going out. So you would have to, on the piece of sheet, you would have to cut out twice this. And let's see, I'm not sure where the best place to position. I'm going to roll it this way. So as you
Wow, this is tricky to hold.
Okay, can you anchor my corner
Yep.
there, Gordo? Okay. That is the half pattern. So if you're going to make two of these and join them together, you'd probably want to leave enough for a seam where you could rivet it together. If you're going to try to weld it together, then you wouldn't need that. So that essentially, I got the wrong one. I thought that,
Is that not it?
well, this is not fitting the pattern quite. Maybe it's just because of my thickness of my chalk, but then this is not right either.
I don't see any of
Let's
the-
see that one. It looks identical, but it may not be.
You want to retrace that?
Yeah, let's see what.
This is the
Yeah. I should have checked beforehand.
So since this is a bigger diameter, it's opening up a lot different than the other one.
It's shorter, I think, and bigger diameter, or maybe just the bigger diameter.
You can see the difference right in here.
Okay, and you cut out this piece. And then he's marked some bend lines on here to get the transition from a square corner to a round shape. So you incrementally bend this in a break, just a slight bit at each one, till you get the round shape. And then you make two of these, and then you've got the shape for a hood going from square to round.
So,
This, well,
Similar to this.
that piece up there, the transition, that would be the same deal. Now, the tin knockers have some pieces where they have one piece on one end and a stem in here with sometimes an angle in it and sometimes a length adjustment, and then a place to fasten the other piece, and they would roll that around. The old coal scuttles that we used to have that had a round bottom and a shape like that, they could have a piece that was shaped like that, and on the other end would have the round bottom, and they roll that out, and that's how they would get their pattern for coming up with it. So any shapes you have, you can make the top and bottom to them and connect them, and this would have to be connected at an angle here. Somehow I may have to have two jogs or just an angle here to get the shape that you would want. It's much easier if the top and bottom are parallel, but it doesn't have to be parallel. It can be a different thing.
It can be any heights that you want,
Right?
and any width that you want. It can be round, or it can like tapered. There's one up there that's got a taper to it. It's rectangular at the bottom and round at the top. And you can also make them offset.
All right.
I think Allison's got that one right there,
Oh,
the offset.
this one?
Yeah, the offset.
There's a
Sorry, I wasn't listening, I was putting stuff away.
Okay, this one is square coming up and at an angle on this side. So it's square there
Right.
and
this
angle
one's
there.
straight.
So that would give you, it would line up on this side and be angled on that side, like the one up there. Now, the same, in my mind, I connect that also to the shovel and the tapered ring. Now, an example of the tapered ring, say you got a client that's got a real fancy flower pot, and she wants you to make a ring for her flower pot that fits right here. She wants that ring to they right up there. So how are you going to make that? One of the guys down in Alabama, Billy Watson, he's a bladesmith. Whenever he wanted to make a ring, he would weld a flat ring, and then he would hammer it to the shape. And I thought, well, that's kind of labor intensive. Okay, so what you do is you extend this line here, extend this line here. And where they cross is the center of the radius that you're going to draw to edge bend this hoop. So you put your compass on here. Now, your length, you take the diameter, pi times the diameter, and that would be your center line length here. And then allow, if you're going to lap it and rivet it, you allow some extra. If you're going to forge weld it, Francis said he never allowed any extra for forge welding. Now, edge bending is, especially if it's thin stock, it doesn't like it. It's not real happy with being edge bent because it starts going off to the side. I've done it 3 ways: by hand on the anvil, which is time consuming. I made a jig for the treadle hammer that had the radius in it. It's like a guillotine tool, and it comes down and it has the top and bottom radius on it. And I run the piece through there 2 or 3 times I can get it. And more recently in my class in April, I bought one of those cheapo tubing rollers from Harbor Freight. Oh, don't say that word. But it worked. It was for tubing 1.5 inches to 2 inches, had 3 sets of rollers in them. And on one of the rollers, I put a little notch in it. We used the 1/8 inch quarter, 1 1/4 by 8. So we put a notch in the rollers. It was an 1/8 inch thick or a little bit smaller, a little grooved with a lathe, and we could crank them through there in just a matter of minutes. It was really quick and easy. I was amazed at how well it can do. Now, if you're going to upset this to weld, again, sheet metal don't like it. You put it in the vise and you hammer on, got 1 inch sticking out or less, and you hammer on it and it's going to go sideways. So how do you prevent that? On the edge of that stock right here, you make it look like that. You put a little dish in it, a little cup in it, a little curve in it, and then it does not waffle so bad. It still waffles some and
You're
flatten
talking
out.
about material and you're bending it that way.
Yeah,
So, yeah.
yeah, it's got a cup in
Give it
it.
rigidity.
Right, that makes it more rigid. So that's been a big help there. Hand me the shovel, Brian, please. Thank you. It's in his cookbook. He's got a pattern for making a male shovel form, which he used. And there's 3 different sizes on the wall over there. He would take a piece of sheet metal and clamp it down to this and hammer it. Did he start hot or cold?
Hot.
Hot. And that makes a series of waffles around here, because you've got this piece out here that was this length, and you're trying to make it to this length. This length is much shorter than that piece of sheet metal that was sticking out here. So what does that mean? That means you're upsetting sheet metal all the way around there. You got to upset that sheet metal, and you can have them different. Now, if you want to,
You gotta fold too when you're doing that, if you don't have it evenly.
yeah, a fold is the thing you want to avoid at all costs, because unless you're good at forged welding sheet metal, maybe Andy could do it. If you've got a shovel pan that you like, then you can do it the same way as we did a while ago. Just roll it out. I'm not going to. And you would take a piece of stock, he used 1/2 by 2, and then you would edge bend it to this shape, a horseshoe, and that's one of his terms that he used, edge bending. Whack it over the anvil is a blacksmithing term used by Francis Whitaker. So, and then once you get it edge bent that way, then you flat bend it. Same way with this, you flat bending is much easier there. Everybody understand everything I said? Anybody got questions?
Now, when you were talking about the ring and the very end for upsetting, and you've got that like a concave, is that just cutting the concave right in the end of the sheet, in the end of your ring?
Okay, you talking about this?
Yes.
I've just put it at the step of the anvil and the peen of the hammer, just cup it. So that the end of the sheet metal looks like that. The end of the ring. It's got a curve in it. Now, the way I make my shovel blanks is I have a male and a female form. And I didn't get around to making the form that goes in here. There's too much other stuff going on. And I put the sheet metal flat over this and the male form on top, and 4 or 5 good stomps. And I have sunk what Francis did was raising. And what I'm doing is sinking the sheet metal into with another piece that looks like this. Now I get some waffles around here, and the anvil and a rounding hammer, and don't let them get too bad. And sometimes then I go back into the form again with the sheet and get it just a little deeper maybe. No, hot I would. I generally use 14 or 16, and I have used some brass. Brass is not good in hot coals and fires, but if it's a show fireplace, they ain't gonna never have a fire in it anyway.
We've all seen those.
Well, the ones that would want a brass shovel would be the ones most likely. The 11 gauge, I'd have to probably go to a hydraulic press. And the other thing, you may need a bar across the end here to keep it from shooting out on you. Okay, we should be cool, James.
You gotta reset that rivet some more.
Portable table gone.
Just a sec.
Gordo can do it. Oh. You're supposed to take Clay's off.
I know. We don't want to pick on you kids.
Tighten this up a little bit more. And then we'll go ahead and put the collar on. And then I'll make it beautiful after that, while y'all are doing something else. That looks like it's gonna.
Well, we still may have a smiley face. I have a sundial at home that I did in Francis' class, and I got pretty far along with it, but I hadn't quite finished it. And he was agitating because I hadn't finished it. So he helped me. He held the header while I hit on it, and I've got a Francis Whitaker smiley face.
Go the other side now. That's better than it was.
It is.
We need some more heat there, big guy.
I think we're about ready to quit on this.
Yeah, I want to just do this side and then we're good.
Okay. We got rid of most of the smiley face on this side, so that's good.
That's good.
So,
Improved
you
visual.
too.
The Texas special.
We've got to have a tool name for Texas. Is that where you want it?
I think so. Yeah, one more time. Others, yeah, that's the side.
That side.
Yeah, that's better.
Quit when you're done.
Yeah, okay. All right, so now we need to do the collar, and James is going to walk us through that. And we'll
We
need
want to put this in the auction.
Sure. You gotta stand close by so they can hear me.
Yes, sir.
We can hear you anyways. James. You have a resounding voice.
Okay, every job has many ways of fastening, and one of the ways of fastening a lot of things is collars. Like you can see in Francis Gate back there, there's a lot of collars involved in that. So on the blackboard I've drawn here, about collars, the length of a collar is the perimeter plus 2.5 times the thickness. And the
Thickness of the collar stock.
of the collar stock. And the taper is 2 times the thickness of the collar material. So we've got today a 1/2 inch square and a 3/2 by 3/8. So that's 7/8 and 1/2. So 7/8 plus 7/8 plus 4/8 plus, you get up to 3 1/4 inches, 2 3/4 inches. And then the 2.5 thickness of the stock up here equals a 1/2 inch. So we cut that stock at 3 1/4 inches.
Really equals 15, 30 seconds, but
Pretty
we're
hard.
blacksmiths and we can't see 30 seconds.
Pretty hard to. So, Alison, you want to heat the,
Sure.
let's see what the tongs are.
The big boy tongs.
That's one thing.
Yeah. Have you got those big tongs or did,
I know, that's the best way.
there they are.
Okay. So our collar stock is 3 1/4 inches. So if we lay that down, put a mark here where our stock is, and then add 3/8 for the taper, for the first taper and the second taper.
Collaring is fairly fast after you've made the collars. It takes a while to make the collars, but putting them on is just, I think you can do them less than a minute per collar when you get organized and get things going.
Turn the tongs over so you get the bevel on the other side.
A lot of times I do it on the far edge of the anvil. Helps me get a short collar. Sometimes I do it on the horn, and sometimes I do it in a treadle hammer with a rounding hammer. But you always narrow the stock a little bit first because you're going to widen it out.
I've got this sample of different collars that I put more contemporary version.
If you're gonna groove or decorate your collars, do it before you cut them.
Yeah.
Yeah. And I usually do it on the treadle hammer, just zip right along with the treadle hammer.
And if you've got a pretty intricate design, as you close the collar up, you're going to want to create a tool that mimics that shape so that when you set the collar flat, you're not getting rid of your design that you created.
You go back and refresh it with one hammer blow. After you've set the collars, you don't want to keep hammering on it, because if you hammer on it, it expands, the stock lengthens, your collar loosens. So the minimum number of hammer blows you can do, the better off, the tighter your collar will be.
You make a mark in the center of the collar, and then about the width of the collar stock that on the side. Put a center punch mark there, or you have a center punch clip.
Oh, where did we have it last? There it is, yeah. Francis looked around the shop to find the sharpest edge vise.
This happens to be probably the sharpest one today.
But it's got the stand on it where you can stand on it. I make the first bend in my collars in a V-block and a treadle hammer. That's quicker and easier for me. One of Francis' sayings was, "There's always a better way," but he wouldn't necessarily accept what you thought was a better way. Pretty rare, but occasionally you come up with one. I never saw Francis do that.
I know, but I was thinking about this last night.
Well,
I was thinking about this last night when he
And-
turned that over. There was a little bit of a curve on it, and I figured that this will give it a little bit sharper bend.
Well, the other thing he did, he always heated it in the fire to make the tapers, so that got the stock pretty. He heated it in the fire, and that got the stock kind of soft for making this bend cold. At least that's my thoughts on it. But Francis changed, like Alison says, he changed his ways at different times. The first class I was in, it was jump well scrolls, and then in a year or so, it was branching towards well scrolls with a folded. He punched hammer eyes with a punch, and then he started drilling them. Two pieces like Eric Mobus showed him, drill two holes the width of the hammer handle, and then you just have to shear out the web. So it's a lot less energy intensive at the anvil. You spend more time at the drill press. Sir.
So our next step is to put this, this way.
Tell them what a collar block is.
This is a collar block. This is the thickness of Alison's job. The 3/8 plus comes to 7/8. So we put this down.
Show the camera and hold it still. Right
There you go.
The short side is down. Okay. Now, we're going to clamp this, put the hammer under it, Alison.
Yep.
They're putting the hammer under it because that bend was a little less than 90 degrees.
Hang on. I'm
And-
not where I need to be.
And that helps get the collar up against the stock. Usually what I do is put a vice grip on the collar block and the stock in this plane, and that holds it together when I'm clamping it in the vise.
If you have a good machinist vise that has that flat box in there,
Like that vice
it's,
over there.
you don't need the hammer. You make a block that's dedicated for this height, and then you don't have that problem.
Yeah.
So we're making do today. So you want to Okay, you wanna heat that?
Yep.
Allison,
Yes.
when you're doing that, can you,
Do what?
can you stand it off to the side here a little bit?
Yep.
Side right there.
You can make color blocks ahead of time if you have time for any size that you want. Hal Harris, a friend of ours, has a whole toolbox full from 3/8 to 1.5 probably.
Francis made them out of mild steel and hardened them with Royal compound. That gives a case harden on the collar, and the edge is real sharp.
Okay, so there's the first step.
James, if you set it on vice and hold steady.
Wait, he hardened them with what?
All right, we got it.
Hardened it with Royal compound. Most readily now you can find casonite. And Royal, I don't know, I've never seen it advertised. It's something he got years ago and had it forever.
You okay with that?
I use air hardening tool steel, A2. And when you get it, it's soft, you can saw it, drill it or mill it. And then once you heat it though, you can't do anything to it except grind it. And that makes really good collar blocks.
Now, bring your job. And we will,
It doesn't matter.
which do you want to be the front? Do you want this to the left or that to the left?
It doesn't matter. Okay.
Let's make sure that. Now, collar fits pretty tight, so we're gonna have to set that.
Well, whether it fits tight or not, you want to set it down hard blows. If it has a bow in the back of the collar, this will correct that.
The pinching thong.
Okay, one of the things we're gonna do now is we're gonna heat the bottom of the collar on both sides, and we're gonna pinch it with a heavy tong. So to get that really tight. This is very important when you're doing a big gate or railing.
And get your collar right at the tangent point.
Okay, hold it a little bit.
Which one you gonna close first?
No, wait. Okay, I made a small error in my tapering, so we're going to file that off to make that level.
And then heat it back up so that the filing marks don't show.
It's a little bit too long here. And there again, if you do some test pieces of your collar on the material, you'll get the right length faster.
Okay.
So, that finishes that.
All right.
Set it up somewhere.
I want to talk about the tenons a little bit. You jumping on my
I'm
head.
having a tough time.
Okay, I would like to talk a little bit about picket length. When you're doing a job on a railing, and you want to make sure that all the pickets are the same length. This is a handy little gauge that Francis taught us to use. You put the tenon in each one of these holes. That's your predetermined width. And the best thing to do is to make them a little bit short and get cold on a flat side power hammer, and you can stretch them till they're the right length. If they're too long and upset them, that's a lot harder to do. That was one thing. The other thing,
But you can put a monkey tool on the end of a tenon and upset it.
if you're having a big railing job that you have to rivet the rail with all your, this being the picket. This would be the picket. So you put the rivet head against this, and this acts as an anvil then. And you can rivet solidly, like being on the anvil. You put the rivet, this is shaped this way. And there's a hole here made with a punch for a rivet. We made these for 3/8, or you can make them for 5/16. You can put them on either side. And they have to be the same height from the anvil up to the center of the hole as the job you're working on. These are made out of old grater blades, and they're very durable. It's very handy. And if you have a longer picket, you can use a post vise to hold the picket while you're riveting the bottom rail. That's all.
Francis used a lot of other backup bars for riveting. Here's one here. He said he liked best that had a piece of pipe on a base, and the pipe has some holes in it so it's adjustable in height.
Or you can use it at the edge of the table also.
Right, you can put it over the edge of the table, put your gate down here, railing down here, and put the rivet head on the inside and then head it from the outside, and that catches over the table to back up. And we got 4 or 5 of these at folk school that he's made over the years.
If you have a footed tenon for a stair rail, it would look like this. So you can make another jig that's similar to that by taking a piece of flat stock and welding this angle.
James, I'm getting too much reflection on the sheet there.
No, I can't see.
He needs Allison's flat black.
Yeah. Yeah, or get that other sheet, Clay.
For sure.
Now this one,
Okay, Carl, can you see that? Okay. Okay, so we have a angle tenon. So you make a jig out of flat stock, weld this angle across the shape, whatever the desired angle is, and you can lay your new, and put a piece in here as a rest for it to sit on. So your new piece would sit on here like this and like this. And you can see if you're the right length or you're too short. And also you can predetermine in your jig where this hole's going to be. And oftentimes you can drill right through the jig and drill through there. And you can stretch this. You want to raise it up off of the table enough in case that you have a twist in your picket. so that you can still stretch it. And likewise there again, if it's too short, you can stretch it cold on the power hammer, but this is a good way of keeping all these angles the same length and the same angle.
There's another problem with a foot, is that the angle of your foot,
Yeah, right.
you can't have the angle of your foot going this way or that way. We duplicated railing that Francis put on the back side of the Keith house going up some stone steps there. And 2 or 3 of our footed balusters weren't exactly square, and it's difficult to square those. This jig, if you have this piece and this piece be perfectly vertical, then your eyeball could tell you that. But anyway, we put that together and we installed it, and the dang railing is leaning. What's going on? So we jury-rigged something to pull it over into shape. And then when we look at that foot down there, that foot had gone off at an angle. It was correcting itself to the slope that it wanted to be at, because we hadn't gotten it perfectly square.
Boy, you gotta square those things. When you forge them, you gotta square them.
All you have to do is...
It's hard to square them because usually the foot's wider than the bar, and it's difficult. If you could clamp it down to the anvil and then put a square on the side or something.
But with this, all you have to do is heat this up and get a big pinch of tones, and you got it square.
Right.
And that saves a lot of time. Okay.
Ready?
Should we do the quadrifoil now?
We might as well.
Yeah, okay.
May I make a comment on the picket line?
Yeah.
Sure.
Yeah.
We would set those, the fittings on there a 16th inch long, because we're almost always fitting hot. And then they would shrink back to the length we wanted.
Yeah, you gotta, if you're gonna use that gauge James showed a while ago, you need to have your material at the same temperature for all of them, either hot or cold, and so that you don't get,
Yeah, but since you're wanting to adjust at the time you're going into
right,
that,
you want it
needs to
hot.
be hot.
Right.
And
So when I was talking to different people who'd worked with Francis about their handy tips, we're going to kind of spend the rest of our time here going over the Quartrefoil and any other handy tips which people
I got a
had
couple of
talked
things I
about.
want to forge.
Oh, okay, good. All right. We wanted to touch on the Quartrefoil because a lot of people, that was something that was on their minds. And Tal Harris actually emailed me some nice description of the Quartrefoil and how he had learned it with Francis. And we have this storyboard up here, which we'll talk about. I'm going to pass this around. The biggest thing that, if we look at, I just drew a quick Quartrefoil up here on the board. The thing that he wanted to add to the conversation about doing a Quartrefoil was when you go ahead and lay out your material, you want to also put a center punch mark on the center of each part of the outside of the Quartrefoil. Because when you go to adjust it, it will be so much easier. Not only do you have these points as reference points, but you also have the center point. So as you're tweaking it for 4 or 5 hours, you can keep lining up those center punch marks. The other thing that Francis thought was so important was to go ahead and draw the circular diameter, which corresponds to your Quartrefoil, as well as the square and center points, because that too will help you to try to adjust your Quartrefoil so that it's as perfect as it can be.
The circle was a big help, and then the lines through it, when you're lining up the foils, those square lines through there would really help you get it, because if you're just doing it on a blank piece, you can go a 1/4 inch out very easily in any direction there. What she was talking about, the Tal suggested putting center punch mark. This is a layout stick where you have nicked this, you decide the size of quatrefoil you're going to make and do the drawing, and then run your traveler around to try to get the length of the stock. And I think he set his fuller for fuller needs at 1 1/4 inches. I told you 1 inch the other day, but in the book it says 1 1/4 inches here. But it doesn't make a whole lot of difference there. But that's his fuller right here. And I don't know. There you can see it now. Well, he's looking at it. Okay, and he used a 1/4 inch round fullering jig.
And he had a stop over here to hold this at a constant level. I don't know where it is today, but you need a stop over here.
Well, these things are 1/4 inch round, and you're hammering on them. They're real flimsy, so they get broken and beaten up pretty regular. They don't have a very long life span.
After that's done, we'll talk about this.
You want to talk about the rest of it?
This step.
Or do-
About this step.
Okay, all right. All right. So you divide the stock into eighths, and you put a nick mark at 1/8, and at 3/8, and then at 5/8, and 7/8. And that's where you're going to make the bend, the fold, this part fold here. Now, when you're getting ready to weld this, you weld twice. You leave the opening here so you can get flux in there. When you bend this, don't smack it closed. Heat it, put flux in there, and then lightly weld it in this plane, the easy way. And then
Set it the other direction that you did.
then he would fuller it here like we showed there. And then he would forge weld this on the end of his little giant drawing dies, a 25-pound little giant. The drawing dies would be hitting here. Sorry, Carl. And he could weld these and they wouldn't come apart. And he wanted a 1/4 inch extra weld there because that first 1/4 inch a lot of times would open up pretty significantly. And then you go ahead and bend them in succession, just going down the line. Usually you'd start at one end and do the next one and go on down. And then when you open them up, you want to have them at a heat so that you get a fairly consistent radius each time when you open it up here, because that's very important. If you get a different radius here than you do on that one, then your tweaking time is doubled, trying to get the thing into shape. And I made a jig where I could, after I welded, I could put it in there and then bend this out over a form there so that both of them would be fairly consistent. And I had a stop on the thing. That helps some. And so after you got them all welded, then you've got to upset this. I usually upset it ahead of time and then scarf it later to do the final closing weld. Then you've got to get things all in shape that Alison had on the board a while ago, so that it would be. Francis tried to figure out the formula for Quartrefoil, like pi d for the diameter of the circle. One letter he sent me was like 3 3/4, and another one I think later was like 4.7 or something like that would be the diameter, or be the 4.7 times the diameter of your finished Quartrefoil, the circle that you were going to put it in. But there's so many variables in the Quartrefoil. You've got each one of these pieces, and then you've got the big curves here that I don't think it's, and you got some links here that all involve. It's not true like a circle is. A circle can only go one place, but this metal can go everywhere in a quatrefoil.
So after you have it formed and ready to weld, you can either weld it on the horn, as we used to do, but Francis came up with this jig, and it really is a time saver. You can just do the weld right there, and makes it so much easier. And there's the completed quatrefoil.
And you can decorate them in any manner you want. And drill a file or grind or
Different
whatever.
decorations.
And that's just the beginning. There's a million ways you can decorate the quatrefoils. Any other questions on quatrefoils?
I'd like to tell a story real quick about the quatrefoil. In one of our conferences, at the end of the conference, Francis always closed the conference, and he was forging, and he looked at the clock, and he said, "Are there any other questions?" And the guy in the back says, "Yeah, how about a quatrefoil?" He said, 20 minutes? He said, "Yes, we'll do it." And he did it, complete quatrefoil in 20 minutes.
I just want to interject a couple other things, and then I'm going to let Blake.
I'll have to call you back. I'm right in the middle of a demonstration.
When I called Dorothy, she was the other night, her contribution to this was, she wanted to talk a little bit more about tenons, and she said that if you can only put a tenon in one place, then do a rectangular tenon, because it's so much stronger. And so I just kind of drew a quick diagram. What she described to me is going ahead, and I guess this would be attached to something bigger. So you would get this hot and sink that through and head it, and then you have something that's really rigid and it's not going to move around.
Won't twist on you near as much.
Yeah, and then the other contribution she was talking about was, again, a strength thing. You can do it either way. You can use a round tenon through a square hole or vice versa. And again, that's another way that you can get a really tight fit.
If you want to have it so it doesn't twist on you, you can come in here and file a small V in here, and when you upset it, actually on the other side, when you upset it, the stock will go into that V, and it will lock it and won't keep it from spinning on you.
And then the other thing, let's see, Brent Curtis was nice enough to contribute, was regarding forge welding. Some notes that he had taken during one of the classes, and I'm just going to pass it around. He also gave me, emailed me some photos. This is the blackboard before it got changed.
Right.
If any of you haven't read what
Where
used
do you
to
want
be
the
up
heat?
there, was up there for like a zillion years. And there's even directions to one of the parties right here. And then they gave this sign, which is now up here, about keeping your hands out of your pockets.
Explain that. Why explain?
Can you please tell that story? Yeah, thank you.
Well, we're talking about this sign up here, and we're doing a interim with Francis and students at CRMS. And we had one student in it that was stubborn about learning how to pay attention to what Francis was trying to communicate to us. And Francis was at the forge, about to do a forging, and the student sat down right here. Needless to say, Francis immediately kicked him out of the interim. But the rest of the students in the interim wanted to apologize to Francis and made that an apology, and it is the don't put your hands in your pocket. Francis felt very strongly about the hands in the pockets thing, and he would really ride anyone who was working with him if they put their hands in their pockets. And his feeling was that every person who was working with him should be ready to help. That is, if you're standing here, Francis is working, be ready to hold something for him, hand him a tool. You don't do that if your hands in your pockets. And symbolically, it means I'm checked out.
Yeah, it does.
And that's what he was saying.
Nice, thanks. And then the last thing that, he had been up to the Fluke residence, which is where, this very intricate railing is that Francis had done. And, I think this is a quote from Francis. Even if your best work is left to rest and adorn Christmas garland, at least you gave your best. And so, anyways, this is a picture of that railing adorned with Christmas garland. So,
Allison, you hold that on the stool right there?
yeah, sure.
Hey, we got that big monkey wrench. You want a monkey wrench?
No, this'll work.
I don't know if he owned that house when this railing was made for that, but the Flukes owned it when I was there. So,
Francis also said that was the hardest thing he ever did.
yeah, this is a really complicated railing. So, anyways, I thought it was fun. You can read Brent's email to me and all that. So, so that's all I have to contribute, I think. And we'll get on with what Clay wants to do.
I got a couple of other things that came across. We were working with Francis at different times. One of them is this forged transition, where you take a piece of stock. We did this in the 98 conference grill, where you go from one plane to the other plane, and it can be straight on this side or straight on that side or straight on that side or in the center of any of them. George Dixon did a test piece with a 1.5, I think, by a quarter by 1.5, and then he designed it with 1 3/4, quarter by 1 3/4, and that made it seem to me like twice as difficult. I don't know. I tried that, but the stock hot here. First, I'm going to do something else, and we'll just do it. And
Are you going to do a 20-minute Quartrefoil?
20 minutes.
Francis says do a 45 here. I'm not sure. But this goes right along with the some of the other things we were talking about a while ago. So I put an edge bend in it.
Do you want all this stuff on the floor?
And we've twisted it the wrong way. Dang. My mind is going blank on me. Not a good time to do that. Anyway, I wanted to twist it a little different than that. But this ends up, you can do the same thing or a lot of the same thing on this piece, where you have one edge goes straight along there, but you edge bend it first, and then you twist it, and then you straighten it out to get where it'll lay flat. One corner will be lined up in two planes.
hold that on the, Clay, would you hold that on the vice, sir? Yeah. Yeah. Perfect.
I've got, my first bend was a little longer than I wanted, but we'll straighten it out a little bit here. Well, that's, I like that especially in tables where you have this 1/2 by 1 bar and you want to be vertical in both side and end. And then you want, where the twist is, you can overlap them, twist one way and one the other way, drill a hole through it, put a tenon in. So you've got the edge bars and the end bars in the vertical plane. So that's a really neat way to make a traditional joinery joint in my glove. Okay, it's a fairly quick way, and you got this edge lined up and you got this edge lined up in one plane there.
Why do you do that 45-degree angle?
Okay, look at the length of this edge and look at the length of this edge. This edge is much longer than this edge. So how do you make that edge longer? You put the 45 or a bend in it. Okay? Questions? You cut this off and drill a hole in it, and this would be on the inside of the table. And then you'd make another one the opposite hand to go with it. That's pretty neat change of plane, I think. And the other piece, what did I do with it? Okay. After they change tape, we can do that if we want to do that. We got about 15 more minutes. So anything else we ought to know? 15 more minutes.
According to the schedule, it's 10 o'clock.
Oh, I'm done.
Yeah.
All right. The tape came out. Okay.